Hey everyone, I am Dijkstra and welcome back to my YouTube channel. In this video, we will be solving today's Leetcode daily challenge, which is path with maximum probability. So let's see what is this question and how we can solve it. So in this question, you are given an undirected weighted graph of n nodes, 0 indexed, represented by an edge list where edges I is equals to a comma b is an undirected edge connecting the nodes A and B, okay, where the probability of success of traversing that edge is this, okay. Given two nodes start and end, find the path with maximum probability of success to go from start to end and return its success probability, okay. And if there is no path from start to end, then return 0. And your answer will be accepted if it differs from the correct answer by at most this number. Okay, so let's see what is this question. So in this question, we have been given with a graph with three vertices 0, 1 and 2 connected with each other in this way and with their success probabilities being this 0 0.5, 0 0.5 and 0 0.2. So first let's see how the graph is created in the question and how it is given in the input. So see, we have been given with n is equals to 3, which is the number of nodes, and then we have been given with an edges vector which represents the edge between these nodes. As you can see, 0 1 is the edge between this node, 1 2 is the edge between this node, and then 0 2 is the edge between this node. And then we have been given with the success probabilities where 0 0.5 is the success probability of the edge 0 0.0 and 1. Similarly, 0 0.5 is the success probability of 1 comma 2 and 0 0.2 is 0 of 2. And then we have been given with start and end node, and we need to find the maximum probability of reaching end node from the start node. Okay, so see here, start node is 0 and end node is 2, right? So as you can see, here are two ways for reaching from start to end, from 0, 1 and then 2. We can go via this way, or there is a direct path from 0 to 2, right? So if we follow this path 0, 1 and 2, then what will be its probability? First we need to reach to 1, its probability is 0 0.5, and then we will go from 1 to 2 and its probability is also 0.5. So its overall probability will become 0 0.25, right? But what if we follow this path 0 say 2 directly? Then its probability is 0 0.2. So among this, which is maximum? 0 0.25 is maximum, and this will be our answer for reaching from start to end. So let's see. So yeah, here 0 0.25 is our maximum probability for reaching this end node. Okay, so let's see another example as well. In this, we have been given the same graph as ever, but this 0 0.2 is replaced by 0 0.3. Okay, so let's see if it is 0 0.3, then still start and end node are 0 and 2, right? So there are two paths 0 1 2 and 0 comma 2. Okay, so this probability will remain same because 0 0.5 multiplied by 0 0.5, but the probability of this path will change to 0 0.3. Now which is maximum? Now 0 0.3 is maximum, not this. So in this test case, our answer will be 0 0.3. Okay, now in the another test case, we have been given with n edges and success probabilities and start and end. So start is 0 and end is 2. But as you can see that we can't reach to end node in any way from the start node. So its answer is 0. Okay, so now let's see how we can solve this question. So see, in this question, we need to find the maximum probability path. We need to find the path of the maximum path with maximum probability so that we can reach this end node. And in the graph questions, we have studied the problem of maximum or finding the minimum distance between two nodes, right? which is solved by Dijkstra algorithm. So in this question also, our distance is just replaced by this probability, and instead of distance we need to find the maximum probability between two nodes. So in this question we just need to apply the Dijkstra algorithm to find the maximum probability between two nodes. So let's see how we can apply the Dijkstra algorithm in this case and find our answer. Okay, so our graph is 0, 1, 2, 0.5, 0.5 and 0.2. Okay, sorry, 0.2. So first of all, we have been given with these edges and success probabilities in different vectors. So first of all, we need to create an adjacency list so that we can access the nodes and probabilities of a node. We can access the neighbors of a node. Okay, so let's first create an adjacency list in which we will store all the nodes and all the neighbors and with their success probabilities. So the neighbor of 0 is 1 with the success probability of this path being 0.5. Okay, and another neighbor of 1 is 2 with the success probability of 0.2. Okay, and similarly we will store the another neighbor. We will store the neighbors of 1, which is 0 with probability of 0.5 and 2 with the probability of 0.5. Cool. And then we will store the neighbors of 2, which is 1 with the probability of 0.5 and 0 with the probability of 0.2. Cool. Now in the Dijkstra algorithm, what we need? First we need a distance vector, right? So we will create a distance vector of size n. Okay, 0, 1 and 2, and we'll initialize it with int min values. Okay. Okay, so now what does this show? This shows the minimum, if we are finding the maximum distance between 2 points, then it shows the maximum distance of this point from the start node, whatever the start node. This will show the maximum distance of 1 from start node, the maximum distance of 2 from start node. So in our question, this is the maximum probability of this node from the start node, and this is the maximum probability of 1 from the start node, and this is the maximum probability of 2 from the start node. Okay, and one more thing what we need is max heap, in which we will store, in which we will iterate all the nodes one by one. Okay, so now let's see. So initially, can we mark it as 1? Why? Okay, so let me tell you. Why? Because our start node is 0, right? This is our start and this is our end. So we are not marking 0 as 1. We are marking distance of start node as 1. Because if we are starting from this node, then obviously we can reach to that node. So its probability is always 1. So that's why we are marking it as 1. And in the heap, we will first push the probability and the node. Okay, so in the heap we are storing the pair of probability comma node. Okay, so now let's start by run this approach so that we can understand how we will get the maximum probability. So now this is the first element in our heap. First of all, we will pop out this element from the heap, and now our node will become 0 and our probability will become 1. Now we will check the stored probability of neighbor of this node is less than or not from the probability of reaching its neighbor node via this node. If it is less than, then we will update this greater probability and push that node in the queue. Otherwise, we will keep on checking for other nodes. So let's see what I am saying. So first of all, we will start iterating its neighbors. Now the neighbor of 0 is first 1. Okay. Now we will check what is the probability of reaching 1. Right now it is minimum. Okay. So we will check whether it is less than the probability of reaching 1 via this node. Okay. So how we will reach 1 via this node? So from start node to this node and then to this neighbor node, right? First of all, we need to reach this node from the start node and then from this node to the neighbor node. Okay. So the probability of reaching this node from the start node is this 1, right? Okay. And then the probability of reaching neighbor node from this node is this 0.5, right? Okay. So obviously minimum is less than 0.5. Then we will simply update this value and then we push this probability and this node in our heap. Okay. Now let's check for another neighbor node. So the probability of another neighbor node, which is 2, is also minimum right now. And we will check whether the probability of reaching 2 via 0 is greater than or not. So first we need to reach to this node via start node. So it is 1. And then from this node to neighbor node, it means from 1 to 2, sorry, from 0 to 2 is 0.2. Obviously minimum is less than 0.2. So we will update this value and then push this value in the heap, the probability and the node. Okay. Now we have iterated all of its neighbor nodes. Then we will pop out another node from our heap. Now our node will become 1 and probability will become 0.5. Okay. So now again we will start iterating the neighbor nodes of 1. So which is 0 first. Okay. So now we will check whether what is the probability of reaching 0 node is 1. Whether it is less than the probability of reaching 0 via 1. So first of all we need to reach 1 via start node, which is 0.5, and then we need to reach 0 via 1, which is 0.5. So obviously 1 is not less than 0.5, so we will not update this value, and then we keep checking for other adjoint nodes or other neighbor nodes. So second neighbor node is 2 now. So the probability of 2 is 0.2. Whether it is less than or not, now let's check for this value. So the probability of reaching this node from start node is 0.5, and then reaching 2 via 1 is 0.5 also. So obviously 0.2 is less than 0.25. So we will update this value to 0.25 and we'll again insert this probability and this node in the heap. Okay. So now as we have created a max heap, so this probability is greater than this. So obviously this element will go at the top and it will get popped out again from the queue. Now our node will become 2 and probability will become 0.25. Okay. So now let's again check for its neighbor nodes. Again its neighbor node is 1 now. So let's check the probability of reaching 1 is 0.5. Okay. Now whether it is less than or not, now let's check. So first of all we need to take this probability 0.25 multiplied by the probability of reaching 1 from 2 is 0.5. So whether it is less, no. So we will not update this value and neither push it in the queue. Now let's check for other neighbor node, which is 0. So obviously its probability is 1, so it will not less than any probability. So again we will not update this value and not push this value in the heap. Now our last remaining element in the heap is this. We will again pop out this element and now the node is 2 and the probability is 0.2. Okay. So now let's again check for its neighbor nodes. The neighbor node of 2 is 1. So the probability of 1 is again 0.5 and whether it is less or not. So let's see. Now this probability is 0.2 and the probability of reaching 1 via 2 from 2 is 0.5. So this is not less this is not less than this, so we will not update it. Again, the second neighbor node of 2 is 0, so its probability is already 1, which will not be less than any other probability. So we will also not update this value and neither push it into the heap. So we have come to the end of all the elements in the heap and popped out and iterated all the nodes. So now what was our end node was 2. So our answer is distance of 2, which is 0.25, as it will give us the maximum probability of reaching that node from the start node. Okay, and our answer was also 0.25 for this path, right, for this test case. So I hope you get this approach. So now let's try code it once and then we'll see. Okay, so first of all, what we were doing, we were creating an adjacency list of pair of int comma double, because the probabilities are in decimals, so it will be of size n. And then we will quickly iterate the edges vector, and then we'll insert this edges of I of 0 dot push back the node, push back the neighbor node and its probability, right? As it is an undirected graph, so we will again need to insert it, as we can go back and forth. So it will be edges of I 0 comma success probability of I, right? Now what we need to do is, we need to first create a distance vector which will be of type double, as probabilities are in decimal, and we will initialize it with int min values, and the start node of distance vector will be 1, and we need to declare a queue of pair of double comma int, and then push the first element in the queue with the probability 1, and then we'll start iterating all the elements of the queue or heap, whatever you can say. And then we will first store the node, and then store the probabilities in double, and then we'll store the probability, and then we'll pop this element from the queue, and we'll start iterating the adjoint, or we can say neighbor elements of this node. And if the distance of this neighbor element, right, the distance of this neighbor element is less than the probability, or we can say the probability of this neighbor element is less than the probability of reaching that element via this node, then we will simply update this with the new probability or greater probability, and push this element with the probability in the queue, right? And by the end, see, if in our any of the iteration, if this value remains min, it means we haven't reached this node. It means we can't reach to the end node from the start node. If this value remains 1, then we will return 0, right? So if distance of end node is equals to int min, it means we have not reached to that node and we need to return 0, else we need to return the distance of end node. So let's try run this. Yeah, it's working fine. Let's try submitting it. Cool, it's working fine. Now let's talk about its time and space complexity. So see, here we need to store elements in a heap. Like here also we are storing these two node or twice with different success probabilities, but we are not sticking in infinite loop because we have created a max heap and it is already iterating for the maximum elements only. And because of this if condition, that if distance is less than this new probability, old probability is less than new probability, only then we will push these node in the heap, otherwise not.